Hello all. So today we'll be seeing about Kernoff map or commonly known as K-map. So these are the contents that we're looking at. That is introduction, construction of K-map, and how do we group in K-map, example, and then advantages and some disadvantages of K-map. So K-map or Kernoff map is a method of simplifying Boolean algebra expressions, and this was found out by Marcy Kernoff in the year 1953. So the scheme map is a type of method where you can simplify any Boolean equation that is given to you. Instead of using a truth table, this method will actually make it easier for you, where you don't need to solve a lot. You just need to use a matrix kind of a thing or a table structure where you need to just input the values and then find out the Boolean equation or the simplified form of the Boolean equation. So in this scheme up, you can either have the terms in the form of sum of products, that is SOP, or else POS, product of sums. And depending on which you use, whether it's SOP or POS, you will be taking up the numbers as ones and zeros. That is the binary values of one for SOP, and for POS it will be zero that you'll consider over there. So now KMAP is a representation that is table-like, but it gives more data than the truth table. So as I said before, it's a table-like structure, but it gives more data than the truth table. So now in a K-map, you can actually have K-map of different types depending on the number of cells. So there are 4-cell K-map, 8-cell K-map, 16-cell K-map, 32-cell K-map, and it just goes on. We'll see further. So construction. So the K-map is construction in form of rows and columns. So for a 2-cell K-map, it will be 2 rows and 2 columns. And for 8-cell K-map, it will be 2 rows and 4 columns. 16-cell, it will be 4 rows and 4 columns. So the rows and column indices are the order in the gray code rather than the binary numerical order. So here, uh, if you see the K-map over here, the 8 cell K-map and the 16 cell K-map, you can see there are a few numbers written at the corner of every box or every table. 0, 1, 2, 3, 4, 5, 6, 7. So these are the numbers that are given in gray code forms. That is, instead of having the binary values, we have the gray code values or the decimal values. These gray code values are given with respect to the binary values that are given on the outside of the table. So you can see you have 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And it is different for a 4-cell schema, which says 0, 1, and 0, 1. So depending on that, you can have the numbering given. So here, because you have three variables, you have three numberings given. So 0, 0, 0, that stands for 0. 0, 0, 0, 0, 1 stands for 1. And 0 and 1, 1 stands for 3. 0 and 1, 0 stands for 2. So that's how it's named. So depending on the binary value, name the cell. And this is how you construct a K-map. So now let's go for grouping. So grouping can be done in different ways. That is, either you just group a single value, or else two, that is a pair, or four quad, and then eight goes for octet, and more than that also, that is 16. So you can see there are a few conditions for grouping. No grouping of odd number of terms. You cannot group other than one. You cannot group any other odd number of terms. That is 3, 5, 7, and all those. No diagonal grouping. You cannot group in the diagonal way. You can only group it vertically or horizontally. And grouping of min terms includes ones and max terms includes zero. So as I said before, for SOP you will group ones, and for POS we'll be grouping zeros. And always try grouping maximum number of terms first. So no matter how many number of values you have, should first see where you get maximum number of grouping. That is, first you should go for octet grouping. That is, you should have 8 numbers grouped. And if you don't have anywhere where you can group eight ones or 8 zeros together, you need to go for 4, and then 2, and then 1. And the grouping method can be different. So you can see over here we have grouped 4 values that is squared in between, and also you can see that there are corner ones. Though you can group them as single pairs, but you don't need to group them as single pairs because there's an option of grouping all the corner values also. It's like considering a cylinder where you can have the grouping done for the edges also. So here you can see the corner ones and all can be grouped. Basically, you can group all the corners, or the 0, 4th cell and 6th cell can also be grouped. 12th and 14th can also be grouped because they are in the edges. So edges can be grouped also. But depending on where the edges are, the edges have to be opposite to each other. So this is how the grouping is done. So now let's see an example. So there's an example given over here, a Boolean function that says z equals to summation of ABC. Summation in the sense min terms. So we'll be grouping ones, and all the values given over here are 1, 3, 6, and 7. So only 1, 3, 6, and 7 will be given the values of 1, and the rest will be given the values of 0. So you can see over here, uh, 1, 3, 6, and 7 are given the values of 1. And you can see that the pairing is done for 2 because you cannot have 8 values grouped over here, nor 4. So we are going for 2, that is pairs or dual. So you can see that it's grouped horizontally over here. And you can also see a dotted line showing that you can also group it vertically at this point. But because we've already grouped these values, you don't need to group it vertically also. It's enough if you just group them once. You don't need to group them many times or add them into many groups unless you don't have any ones left out. If you have any ones left out or any zeros left out, only then you'll be grouping. Because over here you're grouping min terms and you don't have any ones left out after the grouping. You're not grouping it once again. You just leave it with the number of groups that are remaining. That is group 1 and group 2. So you just name the groups and then you find the uh, Boolean function for the group. Over here you can see that 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0 are named. So if you have 0 for min terms, 0 represents the complement of the value. So if it's a, uh, the 0 will be representing a complement, and if it's 1 it will represent a. So just like that, b and c will represent b complement, c complement, and then 0 1 it's b complement and c. 1 1 stands for bc, and then 1 0 stands for b and c complement. Because it's min terms, you will be multiplying the values and then add the total, that is sum of products. So summing up all the products. And over here you can see I've taken group 1 and group 2. So group 1 is the first one, that is the red marked one. Over here you can see I've taken a complement c because uh, for this single row a complement is the value, and over here I've taken c but I not consider b because c is the only value that is not changing. It's 1 and 1, but b is changing from 0 to 1, that is b complement and b. So ignore the value that changes and consider the value that doesn't change. That's why I've taken only c, so it's a complement c. And the next one, the purple one, is group 2, and over here you can see that I've taken a because a is not changing over here, and so I've taken a. And in this you can see that in these two columns, uh, c is changing, so I've removed c and only taken b. Because b is over here 1, which is just b and not its complement. So depending on the number of values that are changing, if the value changes in the row and column, you ignore the value. If it doesn't change the row and the column, you take up the value. So that's how we have done it. And we find a simplified value for the z, that is z equals to a complement c plus ab. That's the simplified Boolean function for it. And that's what is the advantage of using a K-map. It just simplifies the way you solve it. So let's go further. So now we'll be looking at the advantages and disadvantages of using a K-map. So advantage of using a K-map is that it reduces the number of gates and the number of gate inputs. Uh, Consider that you'll have a Boolean function that is not easily solvable. So you'll think that you just need to go for the number of gates that are there in it and make it complex. And the number of gate inputs also will increase with it. But if you are able to solve it easily using a K-map, you will also reduce the complexity of the circuit, which will make the gates and the number of gate inputs also lesser. And over here you can see that it's also given that the cost is reduced. If you don't have many number of gates used in it, you'll of course reduce the cost of the circuit also, and also the component. And it improves reliability. So this method is reliable, very well reliable. That is, it can be used in any number of forms or with many number of cells also. And the graphical notation simplifies Boolean equation in the easiest method. So previously we saw an example where you had a table or a grid structure formed, and it was easier for us to write the Boolean equation for it depending on 0 and 1 alone. You don't need to go for a complex method to solve this Boolean function. That's what makes the graphical notation simplifying the Boolean equation. And then the disadvantages of using a K-map is that with the increase in the K-map, with the increase in the K-map values, you will also increase the number of the cell or the number of inputs. That will also make it difficult to solve the K-map also. Say for a 4-cell K-map, for 8-cell K-map and 16-cell K-map, it should be easier. But think of a K-map where you have n number of cells, or say 64 number of cells, 128 number of cells, 512 number of cells. So over there, it will be harder to group them, harder to solve it also. That's why we don't prefer K-map when it comes to more number of cells. And in such cases, we might go for another method called as Quinn-Mikkelsey method. We'll discuss about that in further videos. So now next we'll go for the next point. With increase in number of cells, the complexity of solving the K-map also increases. So as I told before, with increase in number of cells, you'll also have to increase the complexity of solving it. That is, it will become harder for you to solve a K-map or group the terms, and it might also confuse you at a time. So these are disadvantages, advantages, examples, and other concepts related to K-map. So that's it for this video. Thank you.